All right, today we are going to take a look at pairwise comparison, which is our last voting method. It is very similar to Condorcet, but it is actually a little less strict. Pairwise comparison is also sometimes called Copeland's method because that is the mathematician who developed this method. So, to start off, every candidate is matched head-to-head against every other candidate. So that part is exactly the same as Condorcet. In each head-to-head matchup, the winner is the candidate with the most votes. But if the two candidates have the same number of votes, then it ends in a tie. Now, the winner of the pairwise comparison, the head-to-head matchup, gets 1 point, and the loser gets 0 points. If there's a tie, then each candidate gets half of a point. So that's where pairwise comparison differs from Condorcet. Now, the winner is not the candidate who wins all of their head-to-head matchups like Condorcet. The winner is the candidate with the most points. So if we think about sports, Condorcet, you were looking for the undefeated team. You were looking for the candidate who won all of the head-to-head matchups. But in pairwise comparison, we are simply looking for the candidate with the best record or the most wins. So let's take a look at the math club election again. Remember, we have Alicia, Boris, Carmen, and Dave running for office of the Math Appreciation Society. So we need to list out all of our head-to-head matchups. We have A versus B, A versus C, A versus D, B versus C, B versus D, and C versus D. I'm going to show you the first matchup in detail, but because this part is exactly the same as Condorcet, I am going to move quicker through the other ones. So remember that when you look at a head-to-head matchup, you want to pretend that A and B are the only candidates in the election. So I'm going to scribble out C and D. So if A and B were the only options, these 14 people would choose A. These 10 people would prefer B over A. These 8 people would prefer B over A. These 4 people would prefer B over A. And this last person would also prefer B over A. So A would get 14 votes, and B would get 10, 18, 22, 23 votes. So B wins this head-to-head matchup. And then you go through and you do the same process for all of the other matchups. I am not going to write those out in as much detail. I'm just going to go ahead and skip straight to the results. So in A versus C, it is also 14 to 23, so C wins. A versus D is 14 to 23, D wins. B versus C is 18 to 19, C wins. B versus D is 28 to 9, B wins. And C versus D is 25 to 12, C wins. So far, it is exactly the same as Condorcet. Now, we need to tally up the points. 1 point for a win, half a point for a tie, 0 points for a loss. So, A lost, lost, lost. So A has 0 points. B has a win, a loss, and a win, so that's 2 points. C has 1, 2, 3 wins, and D has 1 win. So our pairwise comparison winner is the candidate which is with the most points, which is candidate C, Carmen. Now, Carmen is also our Condorcet winner because she won all 3 of her matchups. Now, let's take a minute and think through some of our criterion. So remember that the majority criterion and the Condorcet criterion are the most common rules that we look at. Majority criterion. If there is a majority winner, will they win by pairwise comparison? Well, yes. If a candidate has more than half the votes, then they will beat every other candidate in every head-to-head matchup. Now, Condorcet criterion, because the setup of Condorcet and pairwise are the same, we are talking about head-to-head matchups, then obviously if a candidate wins all of their head-to-head matchups, then they are going to win the most matchups. So pairwise comparison satisfies both the majority criterion and the Condorcet criterion. So what's wrong with it? I told you that every method has something wrong with it. Well, let's introduce our last criterion. It is the independence of irrelevant alternatives criterion, which is a lot of words. But if a candidate wins an election and then somebody who does not win drops out, then that winner should still be the winner. So basically, if a loser drops out, the winner should still win. Well, let's look at an example. The NFL has decided to bring back the Milwaukee Badgers, a team that only lasted from 1922 to 1926. They will be getting the #1 pick in the upcoming draft. The coaches and executives meet to discuss the candidates, Allen, Byers, Castillo, Dixon, and Evans, and choose the team's first pick in the draft. By team rules, the choice must be made using the method of pairwise comparison. Okay, so we have our preference table here. We have 5 candidates, A, B, C, D, and E. We are going to list out all of the head-to-head matchups. Okay, so we are going to go through and look at each of these head-to-head matchups. I am just going to go ahead and write the number of votes and circle the winners in each matchup. I am not going to write out all of the details. So in A versus B, it would be 7 to 15. A versus C, 16 to 6. A versus D, 13 to 9. A versus E, 18 to 4. B versus C, 10 to 12. B versus D is 11 and 11, so we have our first tie here. B versus E, 14 to 8. C versus D, 12 to 10. C versus E, 10 to 12. And lastly, D versus E, 18 to 4. So now if we go through and count up the points, how many wins did A have? 3. How many wins did B have? 2 and a tie, so that'll be 2.5. C had 2 wins. D had 1 win and a tie, so that's 1.5 points. And E had 1 win. So our winner is A, Allen. Now, let's suppose that Castillo drops out of this election. So maybe he gets injured, decides not to go pro. For whatever reason, he is not a part of the draft. So we're going to redo these calculations with Castillo eliminated. Okay, so again, you're going to look at this adjusted preference schedule and figure out who wins each of these head-to-head matchups. Okay, so when we look here at the points, oops, not C. A wins 2 matchups, B wins 2 matchups and ties, D wins 1 matchup and ties, and E wins no matchups. Well, now who has the most points? B, which was Byers. So pairwise comparison here, you can see does not satisfy our new criterion because we had a person or a candidate drop out and that candidate was not the winning candidate. And now we have a different winner. So Allen was originally the winner, Castillo dropped out, and then Byers became the winner. So pairwise comparison does not satisfy the independence of irrelevant alternatives criterion. Let's take a look here. We've mentioned this before. How many pairwise comparisons do you have? Well, let's suppose that you have 10 candidates, A through J. How many head-to-head contests will there be without having to write them out? So, in general, the rule is if you have n candidates, you do n, choose 2, and that will tell you how many head-to-head matchups you have. So, if you have 10 candidates, 10 choose 2 is 45. So, practical application of this. In a round-robin tournament, every player or team plays every other player or team once. You are in charge of scheduling a 32-player tournament that's a round-robin tournament. How many matches, games, whatever sport it is, will you have to schedule? Well, you just do 32, choose 2, and you get 496 matches, which is a lot. So I hope that the people running this tournament have a large facility. Now, we have one more thing to cover. So, if you want to open up your notes from our previous two sets of notes on plurality and Condorcet and board account and plurality with elimination, we are going to refer back to previous problems that we've already done for our last topic, which is rankings. So, in the real world, sometimes it's important to just know who won the election. Sometimes it's important to know who finished second, third, fourth, etc. So this is called the ranking of the candidates. And all of these methods are called extended whatever method. So extended plurality, extended board account, extended plurality with elimination, and extended pairwise comparison. So we are going back to the math club election. So if you go back to your notes from the first day of this unit where we looked at plurality, we want to rank all four candidates, Alicia, Boris, Carmen, and Dave, according to the number of first place votes they got. So we had said that Alicia was our winner by plurality because she has 14 first place votes. Well, what if we care about all the other places? Carmen has 11 votes, so she is in second place. Dave has 8 first place votes, so he's in third place. And Boris has 4 first place votes, so he is in fourth place. So that is our ranking for extended plurality. Next, for extended board account, you calculate the number of points each candidate earns using the board account method, and then you rank them according to the number of points. So, Boris was in first place with 106 points. Carmen was in second place with 104 points. Dave is in third place with 81 points. And Alicia is in fourth place with 79 points. Now, plurality with elimination, you do need to pause and think about this. The first person to be eliminated is going to be in last place. So when we did plurality with elimination, Boris was the first one to be eliminated, so he is in fourth place. The second person to be eliminated was Carmen, so she is in third place. Then we narrowed it down to just Alicia and Dave, and Dave ended up with a majority, so Alicia is in second place. And then lastly, extended pairwise comparison. We just rank the candidates by the number of points that they received. So Carmen won all 3 of her head-to-head matchups, so she's in first place. Boris won 2 of his head-to-head matchups. Dave won 1 of his head-to-head matchups, and Alicia won 0 of them. Now, you can see that all 4 of these voting methods give us different rankings. So, which one is best? Well, as we've seen, all of them have their flaws. Some of them violate the majority criterion, some violate the Condorcet criterion, some violate the monotonicity, and some violate the independence of irrelevant alternative criterion. None of these voting methods is perfect. They are all used in different situations, and sometimes they all agree. Sometimes you can get vastly different answers with each voting method.